Hello everyone. In this tutorial I want to show you a couple of things. One thing I want to show you is what if in your data set you don't have too many categorical variables. For example, you need categorical variables to do your chi-square test, and you also need a categorical variable to do your ANOVA. So if you don't have too many categorical variables, you need a categorical variables to do your chi-square test to find out if two variables are associated or not. And you would also need a categorical variable as a grouping variable to do your ANOVA. So as an example, I'm using Eliza's data file again, and in this data file Eliza has this variable called GDP last. And so obviously you can see that this variable is a scale, and so these are not categories, right? So when I say categories are something like this. So Eliza has this variable which is 1 and 0 here. So this is category. These categories are not labeled, but if you look here right now, so Eliza has 1 is for left and 0 is for right. So I'm just going to write down here for example, so in this case 1 is left and 0 is right. So this is the categorical variables here. This is categorical variables. We just label them. So this is categorical variables, and one other way you find out is a categorical variable is by looking at the measurement. So measurement is nominal because categories generally categorical variable doesn't have a degree of hierarchy. So this is categorical variables, so which is good. But in this particular example, this variable has only two categories: yes, right, or left, for example. And if you want to do ANOVA and you want multiple categories, if you do run ANOVA, then two categories will not be enough, because if you have two categories, you can simply do your t-test. So I want to show you right now is how you can take this existing variable. So let's say I'm just going to run a quick frequency here, a descriptive stats frequency, and I'm going to choose this GDP per capita variable here, and you can easily see that in this here you see that GDP goes somewhere from 1.73 US billion dollars to all the way to something very large number, 25,705 is probably USA, I think. And then there is a 1.73. And of course, I mean, if you think for a second, one of the contexts about GDP is also the size of countries. So normally the smaller country will have a smaller GDP compared to the larger countries. So right now this is not a category, this is some simply numerical variable. So how can we decide how to make this into a category? So answer is not relatively simple, but for the simplicity, as a purpose of exercise, just to show you how you can do it. So I'm just going to take a easy cutoff point, and since this data set doesn't have too many cases, I think they have just little over 70 cases, and so if you make too many categories, then each category will have a very few samples, so it's not necessarily a good thing, especially if you're dealing with a small sample. So I'm not going to create too many categories, but if you look at distribution, so I'm just going to basically right now I'm just going to choose some arbitrary number. So let's say the first category is I'm going to choose a GDP less than 20. It's about 1/3 of the observation. Then I'm going to choose GDP up to 300, so that's about another 1/3, and then whatever remaining 1/3. So what I did was I look into this variable, and I just arbitrarily decided to divide this data into 1/3 approximately. Okay, so that enough. So making sure that there's enough cases. So this is my criteria here is, but if you're dealing with the real data in the real life, so every time when you divide data into categories, there has to be some sort of a reasoning, there has to be some sort of rationale behind it. But as I said, for the sake of this exercise, I'm going to show you how you can take the existing skill variable, this is skill variable, and divide it into categories. So just watch these steps very carefully. Okay, so you go into your transformation, compute, actually go into the recode, recode into different variables. Just make sure that you click on the different variable, because if you recode the same variable, then your existing variable will disappear into new variable, and what if you messed up with your existing variable, then you will never able to recover back. So I always record into different variables. By doing that, I will keep my old variable as it is. So of course, as I said, we are recording GDP per capita in this example, so I'm just going to call it a new name. So I call it GDP, and we call them let's say it's a last, so GDP last of the country, and I'm going to record. The reason I'm writing record because I'm recording this variable, okay. And of course you can label them as it will be GDP last, which is in US dollars, for example. I think it's in US dollars in billions, so this is the GDP. So I just label them, all right. So of course you click on the change, and the next is asking old and new values. So click on the old and new values. So it's asking what value do you want to say. So remember, I mentioned that I want to go all the way to 20, so it will be so less than 20. So I'm just going to choose 19.99 as the so this represent less than 20 USD. Okay, so this will, I'm going to call it 1, code number 1. So and when I say add, you see it's saying lowest throw 19.99. so it's basically, this is my first category, less than 20, so code number 1. The next one is between 20 to less than 300, so I'm going to call it 20 to 299.99. so this is become 2, so I'm going to call it a 2. So you can see that 20 throw 299, basically 20 throw less than 300, so category 2. And then my last value, I'm going to call it so this is next number will be 300, so 300 plus, so I'm going to call it the 3. So here it is, and yeah, so you can see that it's very nicely laid out. So it's less than 200, less than 20 is 1, 20 to 300 is 2, and 300 above is 3. So this is how I did code, and this is exactly, this is you will do code. So look at your variable you want to code and decide some criteria, and this is how you're going to do it. Okay, so I'm going to say continue, and here it is. And once I'm going to say okay, and you see that I have my new variable. See, this is the syntax of my code, exactly what I was talking about. Recode GDP last into this code, lowest through 19.99, which basically implies it's less than 20 is 1, 20 to less than 300 is 2, 300 and plus is code number 3, into a new code called GDP last recode. All right, and this is my new variable list. And if you go back and look at the end of this data, here it is. Look at it, my beautiful new code is ready here. You see that beautiful new code is right there. And of course, before you forget, and you see this is nominal now. Okay, now this is slightly interesting because even though it's a categories right now, but the number has meaning, because obviously you can see that the higher the GDP, higher the number, higher the GDP. So I'm going to decide as an ordinal, not as a nominal, because ordinal means you can order this category. So I'm going to call it ordinal. Okay. Nominal mean no, the categories doesn't imply, but ordinal means the categories number means hierarchy. So obviously category 3 is higher than category 2, category 2 is higher than category 1. So in this example, category 1 was less than 20 USD dollar. So I'm just going to write down dollar because we already know that this is in billions. Okay, so $20. So maybe I should write down here. So it's in billion. Okay, so I'm just going to write down billion here. Maybe I should write down like this, billion. Okay, okay, this is US actually. It was US billions. Okay, so this is 1. So I'm just simply now going back and labeling. The reason I labeling right now is quite often once you record them, and if you don't label them, for example, then let's say you want to go back and look at the data file after, let's say, 1 month, right? And assure you will not remember if you do not label them right now. So it's a good idea to label your data immediately you code them, so this way you have documented. And also, what if you are giving this data file to your team members to do some more analysis, for example, right? And if you don't label them, they probably will have no idea what this number really means. So it's a good practice. It's always a good practice that any data you have, you should always label them and provide as much as information possible. You see what I just did? So I just labeled those codes right now. Okay, and if you go back to data view and now look at this one, right? So this is nice, right? So we have nice labeled them. So what we got here is you see, from this we have this. Beautiful. Okay, so this is what we got here. Okay, now I want to do a quick demo of just to show you can we do a one-way ANOVA, for example. So we can do a quickly one-way ANOVA, even though in my previous tutorial I explained one-way two-way ANOVA, but this is not a bad idea to kind of do a little demo for this purpose. Okay, so so let's do a little demo here. Okay, so so I'm just going to take this GDP. Okay, and maybe we should use I guess we can use we can choose between the death rate and the recovery rate. So let's choose recovery rate. Okay, that would be interesting. Okay, so so I go analyze. Okay, I'm doing a one-way ANOVA. So here's a one-way ANOVA, and now because I already created my new variable, this GDP, so this goes in factor, and I'm looking at the recovery rate. And the one good thing about using a SPSS, you can choose multiple variables. For example, this way you can try different variables. So let's try death rate and recovery rate. Find out. So basically, what we are really saying is this is GDP has no impact on recovery rate or the death rate, whereas the alternate hypothesis is that GDP does has effect on the death rate and recovery rate. Let's find out quickly here. So I'm just going to say okay, and we have a very quick result here. So so you can see that is the both death rate and the recovery rate seems to be significant. This is a very interesting result. So let me quickly look at the data right now of ELISA. And so yeah, so this is very very interesting. So we do see that there is they both are significant variables. So you can see that the both numbers are significant actually, which is very very interesting. So you can see that the both numbers are significant. COVID-19 death rate and COVID-19 recovery rate, the both are significant. The both values are less than 5%. So this is super interesting. So because the result is significant, and then you can ask for more analysis. So I'm just going to choose, let's say, recovery rate as a one example, and I'm going to do my post hoc test because I saw the result is significant. And in option, I'm going to look at the homogeneity variance test. I can plot the mean plot, maybe look for descriptive stats, for example, and just simply run this test here. So we already saw this one ANOVA result showing up significance here. Okay, and one interesting thing you want to make an observation is this is the so of course one of the question we are interested in which group is more significant, right, compared to. So you can see that is countries who has a higher GDP. Okay, the main difference is in terms of recovery rate tend to be lower than the countries which has a lower US dollar. So it's kind of implies that it seems to be a smaller economy are relatively doing better in terms of their recovery rate. At least that's what the data is showing up, and you can see data here also in the chart also. Okay, and you can see that this is the numbers showing up how many cases are in each of those groups. Okay, so seems look like, as you can see in this example, um, that higher economy, the 300 plus $1 billion economies, here you can see that those countries, the difference, mean difference is in negative. So normally negative, only time when you see negative, when the smaller GDP countries recovery rate is higher than the large economy, and they are significant. Of course, the lower economy is 0.062. Given this is, I mentioned in the beginning of the course that because sample size is smaller, so I ask you can use alpha 10%. So this is less than 10%. So it's a 0.62. Even if you use alpha 5%, so this is very close to 5%, so 6%. So this definitely indicate a direction here. Okay, so so this is what it really look like. And if you look at the plot, so you can definitely see that the recovery rate for the higher economy, you can see this number, right? The higher economy is recovery rate is way lower than the country which has a lower economy, for example. So that's kind of very interesting, actually. It's very interesting, actually. So again, that's interesting finding, as you can see that, and that's something you want to think about it when you write your report. But this is what really a one-way ANOVA look like. Okay, and I'm also going to do show you two-way ANOVA since I'm at it. And what I want to show you is maybe I can take one more variable here just to decide what variable we want to use as a second factor. So we have this variable, I think here's a mask political. I think they have this mask political, and so maybe we can use this mask political, for example, just as a interesting to analyze. So let's see what Eliza has used. So Eliza has used 1 for yes and 0 for no. So we're going to label them here. So 1 for yes, that it's a political issue, and 0 for no. Okay, so 0 for no. Okay, so we got these two variable, and so I'm just going to make sure I've saved this my changes. So I'm just going to go and run the two-way ANOVA. Okay, as illustration. This is what I'm really doing is I'm just doing illustration so that you know how to do recoding and how to do a one-way ANOVA, two-way ANOVA. Okay. But in terms of data interpretation and the quality of data, that really depends upon all the analysis, depends on quality of data and how you interpret your data. Okay, so I leave that to you to decide in terms of would you interpret your data and how you analyze them. At this point, I'm not giving interpretation in terms of what the results coming out. I'm trying to show you how you would do your one-way ANOVA and two-way ANOVA. And also I'm also going to show you how would you do your chi-square test, and plus I showed you how you have you can do the recoding of the variable. So let's do a two-way ANOVA. And if you probably remember, if you have seen my second tutorial on spss, if you haven't seen it, please make an effort to watch it. It's pretty good. So I'm just click on the univariate, right? So when you do a univariate, you want to select your outcome variable. So let's say I'm going to select, in this example, I'm going to select that's a recovery rate one more time as a dependent variable, and then I need my factors, right? So I already have GDP as a factor number 1, and I'm going to also select this another one. Another factor will be this mask, if mask is a political issue. Okay, so I got this. And you notice that when I'm selecting dependent variable, you always select the scale variable. You see the little scale right here? That's very important. Okay, so scale represent it's a quantitative variable, it's a numerical variable. And in my fixed factor, my factor A and factor B, these are categorical variables. Okay, so as long as they're categorical, it's okay. You see that my GDP is a ordinal and my mask is my nominal, but that's okay because both are still a categorical. And one other way you can note categorical is when I assign numbers to the categories, which you just saw when I was giving 1 is for yes and 0 for no. Okay, and when I was giving for the different GDP categories 1, 2, 3. Okay, so so right now what I'm going to do is I'm go ahead and do the plot, just in case the plot is interesting, and especially when you do the interaction plot, just to see if there's differences, if there's interaction. So I'm going to use the GDP as a horizontal axis. and political marks as a separate line. And I think I already explained in my previous video if you watched it. I normally use the variable on a horizontal axis which has a more labels. The GDP has a 3 labels, whereas the mass political is a 2 labels. And leave the line chart as it is one more time, and I'm doing a post hoc just in case if GDP is significant. All right, and I'm going to click on my Tukey test, and I'm going to say okay. All right, so this is the data set. I'm using one of the student from your from the class, and you can see that in this one, which is this is a result. It's an interesting result. You can see that. So we already saw in when we did 1 we do see that the GDP was significant, and you can definitely see here also the GDP is significant variable. So GDP is a significant in the recovery, for example, of the COVID recovery, right? So this is showing up. This is showing up the p-value, the significance p-value, and mass political is not significant. You can see that. So so recovery, the politicizing of the face mass is not a significant in recovery, for example. So political issue is not a concern for recovery rate. Okay, but this is very interesting. You see the GDP last GDP of the country and the political marks. So there is the intersection is not significant. You can see that here is 0.362. Even it's not significant, but interesting point is this political marks by itself is super not significant. You can see it's almost like 0.7 p-value, which is way higher, right? But when it's combined with the GDP, it seems to be there is some traction. Again, I would not say it's a significant because it's not significant, right? Given small sample size, it seems to be, it's kind of a little bit indication of that perhaps there may be a, depending upon economy of the country, there seems to be the issue, the political issue seems to be might be something happening in that particular country, for example, right? As I said, this is not a significant value, but comparing to this 0.669 and 0.362, the 0.362 is definitely way smaller. Okay. So you can see here same number with similar number we saw previously. So you can see that is the high economy tend to have a lower recovery rate, and you can see the comparison, they're all negative values. Okay, so you can see that. And just to make a point here in this example, as you can see that is the 20 to 300 US billion dollars. This is way more significant than the other one, but same issue as I mentioned. It's still, this definitely indicates that the lower economy tend to do way better in terms of recovery. Okay, and this is very interesting chart. This is the chart I wanted to show. So again, as I said, statistically it's not significant, but definitely there seems to be some interesting patterns noticing. So the point here is this is for example, the first line is no, so you can see that is and this is the y-axis is a recovery rate. Okay, recovery rate, the y-axis, and when you notice that is when the issue is political, the yes, the second line, this line, right? So you can see that the lower economy has a high recovery rate, right? And then followed by the medium economies, right? But what interesting contrast is the countries which has a very high economy, you can see that, right? There's 300 billion USD high economy. So where the issue is our mask of political issue, where the mask of political issue, the drop when it's a political issue is way more higher. So this is kind of very interesting result. I mean, if you think for a second, so countries which are super rich, high GDP, in those countries where the mask are political, the recovery rate is very poor compared to where the political issues is not issue, right? For example, you know what I mean, where the mask are not political issue compared to those where the political issue is, and the drop is much more sharper. So this is a again, this is not statistically significant, but this is an interesting pattern to note. All right. So this is basically is your two-way ANOVA test, right? Again, you can see that if you love data analysis, you can really learn a cool stuff doing data analysis, and also you can make a good report. You can make a good commentary about your analysis and about the result. You can see that the data you collected is very powerful and very interesting, and if you collected your data well and you do a due diligence, making sure, because again, I cannot authenticate the data I'm using because this is a student data, and I don't know how the data was collected. I cannot verify that information, but assuming the data the student provided I'm using is authentic, is collected in the right way, then definitely the data has a lot of good stuff to talk about and to do. Okay, and so this is how you do your 1-way ANOVA, 2-way ANOVA. Okay, now I want to do one final thing, is your chi-square test. So as I said, the chi-square tests are very good test, especially if you want to compare two categorical variables. So let's do a quick as illustration again. So what I want to do is just as illustration. So we have this GDP and a political mass political. So these both are categorical variable. So our null hypothesis is that the economy has no impact on political issue of the mask, right? Mask are political or not. So that's our null hypothesis. Is alternative hypothesis is that no, the GDP and the political marks are associated. So what you try to say is this: in your alternative hypothesis is the country where the economy is very high, then the mask issue is more prevalent. The political issue of the mask is more prevalent than country where the economy is not very high. Okay, you got the idea. Null and alternative hypothesis. Null hypothesis is that GDP has no impact on the politicizing of the mask. Alternative hypothesis is that the GDP and political mass issue are related to each other. In other words, the GDP has impact on politicizing of the mask. Okay, so how you do it, just watch carefully. It's a pretty cool test. Okay, so analyze. This is analyze. There's so many ways you can do. The one easiest way I use is called crosstab. So if you watch my lecture video, you see crosstab is also known as contingency table. So you click on the crosstab, okay, and then you have this menu here. Okay, so this is all blank menu right now. So there is a variable GDP of the country. So I'm just going to use a GDP in a column because so I can compare different GDP by this our mask a political issue. Okay, so our mask political issue in a row and column. So again, one of the question you're probably wondering, what criteria do I use to decide what goes on column and what goes on row? One of the things I use in my cross tab, which I'm doing right now, this cross tab here, is typically the socioeconomic demographic variables. I use them in a column. Okay, and whereas the variable I'm trying to investigate, I use them in a row because I'm trying to find out if GDP has impact on the marks as a political issue. So that's why I use this as a row. Okay, so this is what you do, and there are a few more things you can do. There's a cool cluster chart, so you can look for cluster chart, which is kind of give you a nice cluster chart. So I'm going to show in a second. And there's a few things you can do in the statistics. Click on the statistics and check on the chi-square test, because that's what you want to do, the chi-square test. Okay, and then you go on the cell, and I will select the column percentage. Okay, so I can see then yes or no as 100. You're going to see in a minute what I'm talking about, and leave everything as it is, and that's pretty much it actually. And you simply say okay. And what you have is a chi-square test result. Okay, so this is very interesting. You can I'm going to show you this one first. So this is the our mass of political issues. All right, so this is the variable yes or no, right? And this is GDP. So what I want to show you is this. So you can see that is and this is very interesting because we're interested more in the yes. Okay, so you can see that is as the economy increases, you see this from 220 US million to 2300 or 300 more, you see that the political issue keep increasing here. You see this for lower economy, less than $20 billion US economy, their mask as a political issue is only 8.7%. Now the number is doubled up in 20 million to 300 million, right? But look at the 300 plus million dollars. It's like almost like 41%. It's up, you know, which is huge jump. So this is definitely is a very interesting result. You see that, right? So you definitely say that the richer country, the mask as a political issue is more prevalent than countries where GDP is lower. Okay, and you can see that this is called the chi-square, the Pearson chi-square. This value is your p-value, asymptotic significant, two-sided. So this is your p-value. Okay, so this is your p-value. P-value is less than 5%. So therefore you reject the null hypothesis. Null hypothesis was GDP and mass a political issue are independent, but now you're saying that GDP and mass political issue are not independent. As a matter of fact, GDP has an impact on the GDP and mass as political issues are related. So it seems like higher the GDP, more the mass as political issue. All right, and then we can also see this also. This is kind of a beautiful chart. This is a nice chart. You can also see that as this is the both chart tell the same, both bars tell the same story, yes or no, but we are focusing right now on the yes. You can see the nice pattern happening as the issue as the economy increases, US GDP increases, the mass become political issues also increases. You can see in the huge jump here, right? So that is your chi-square test. So chi-square test is very powerful. I mean, so in a way, you can see that in a way that both ANOVAs and this chi-square test more or less leads to the same result. But chi-square test is another way where you can compare your categorical variables and have a nice, beautiful chart like this and result like this. Because sometimes depending upon your audience, sometimes people like numbers like this. So you can show them, hey, 8.7, 15.4 to 41%, for example, and you can show some chart like this. Okay, and of course you can always change the property of the chart. By the way, you can double click this chart and you can change the properties of the chart if you want to change instead of count. You can change percentage, for example, if you want to show the values on the top of this bar. So you can play around here, for example. So I'll leave this to you. You can play around some of those, the format, for example. So there is a few you can play around here. And yeah, so this is your chi-square test. Practice doing in your own data set, but just remember, when you're doing a chi-square test, you want to make sure that you do have a categorical variables. All right, so this data set I'm using is Eliza's. This is Eliza's data set, but of course your data set may be different than this data set, so it doesn't really matter. The whole idea for right now, this exercise was to do a demo, how to convert this scale variable into a categories. All right, and how to do one-way ANOVA, how to do a two-way ANOVA, and how to do this chi-square test. All right, have fun practicing it, and of course, as usual, practice it, and if you have questions, reach out to me.